In this video, we're going to talk about why we need programming languages. We've been talking about the idea of an algorithm, a sequence of steps that solves a problem. And we talked about how in order to effectively communicate an algorithm, we need to know what tools we're working with, and we need to have some shared experience or understanding of those tools so that we can communicate our plan effectively to another person or thing. And the fact of the matter is, when we're communicating with a computer, we have to be even more precise and careful than if we were communicating with another human being. Because the fact is, computers aren't great at understanding natural language. In other words, they're not good at understanding regular English. Even humans get confused by regular English sometimes, and we are much, much smarter than computers. For example, if I said to you, I saw the boy with binoculars, would you be able to tell me whether it was the boy who had the binoculars or whether I had the binoculars? You can't really tell, right? Maybe I was using binoculars and saw the boy, or maybe I saw a boy walking and he had some binoculars. In everyday life, we'd be able to use context. We'd maybe be able to look around and see the boy. We'd be able to ask follow-up questions. And so we would be able to use our own intuition, understanding, and context to assess the situation and make sense of the sentence. But computers can't do that. And so we have to be really precise when we're communicating with a computer. Another important fact to realize when communicating with computers is that computers' preferred language is binary. Binary is a number system where all the information that can be represented using a combination of zeros and ones. And that's really hard for human beings to understand. If you just see a big list of hundreds or thousands of zeros and ones, it's hard to intuitively make sense out of that as a human being. But it maps really well to how computers think because they're built with electronic circuits that can either be on or off. And so typically an off state maps to a 0 and an on state maps to a 1. And so those zeros and ones are telling the computer which circuits to activate in order to carry something out. So computers don't like English, and we have a lot of trouble understanding binary. So how are we going to communicate effectively? Well, we all need to compromise. So instead of writing computer programs in English or writing computer programs in binary, we choose to write programs in a high-level programming language. That's a sequence of commands and rules that convey meaning to the computer, but can also be read fairly easily by human beings. So it makes it efficient to translate those instructions from something that's human readable into something that is binary number related so that the computer can carry it out. We're going to be using a high-level programming language called Python this semester. We'll be using Python 3, which is one of the versions of Python, and we'll be talking all semester long about the tools that are available in the Python language to solve problems. Whenever I think about those tools, I think of them as like a little toolbox that you carry around. You can tackle any problem in the world if you have that programmer's toolbox. And surprisingly, it just has 6 common ideas in it. The programmer's toolbox contains variables, arithmetic expressions, input and output, conditional statements, repetition statements, and functions. If you master those 6 key ideas, you can write any software on the planet, anything from an app on your phone to something that launches the space shuttle. All of them are built using just these 6 key ideas. So as we're approaching our Python learning this semester, we'll be focusing on these 6 ideas, how we can use them in problems, and how we can write them using Python. Before we end this particular segment, let's look at some examples of everyday algorithms. Just to review everything that we know about algorithms. Remember, an algorithm is a finite sequence of steps that can be used to solve a problem. And you use algorithms all the time. It's not something that's just specific to computer science. So for example, if you looked at your shampoo bottle recently, you might have noticed that it has an algorithm on there. It has directions: wet your hair, apply shampoo and work into a lather, scrub your scalp thoroughly and rinse with warm or hot water, repeat, use daily as required. So it has a sequence of steps, and you can carry those out to solve a particular problem. Another kind of algorithm that you might be familiar with is a recipe. It has a list of tools that you need, and then it has instructions for using those tools to create something. So I Googled something about snacks you could make in your dorm room, and the ever popular Rice Krispie treats came up. So we'd need butter and marshmallows and Rice Krispie cereal, and then we could carry out these instructions to create a tasty snack for ourselves. So those are just two examples of places where you've used algorithms, where you've seen them in your everyday life. And again, this is something that's not unique to computer science. You create algorithms all the time for just about everything: what you're going to wear today, how you're going to organize your afternoon, how you're going to drive from your house to your favorite restaurant. All of those involve algorithms and problem solving. And part of what we'll be doing this semester is enhancing your problem solving skills so that you can communicate information about algorithms better.